Hi everybody, welcome back to the second part of Algebra. Hopefully you guys did an alright job on the first assignment. It was a little tricky, there's a lot of new vocab words, but you're going to get better at it every time you do some problems and keep on working on it and stay positive. Alright, let's do another number machine challenge. This is a tricky one, so when we complete all the numbers, pause the video and see if you can figure it out on your own. And I'll be impressed if you can. So, we've got our input, output, and remember, different names for input. Input could also be called X or the domain, and output could also be called the range or Y. So without further ado, let's start the number machine. What's going in? We got a 2 going into the number machine, and the 2 is going to turn into a -6. All right, next number going in the number machine is a 0. A 0 is going to go in the number machine, and it's going to turn into a -2. And finally, the last number to go in the number machine is a -3. And the -3 is going to turn into a 4. So, see if you can figure out this pattern, and I'll be impressed if you can. Pause it, try it, and I'll help you when you get back. Okay, I'm going to help it out. The pattern was multiplying by -2 and subtracting 2. So, let's look and see if it works. 2 times -2 is -4, and -4 minus 2 is -6. 0 times -2 is 0, minus 2 is -2, and finally, -3 times -2 is a +6, minus 2 is 4. So that is tricky, but you keep watching. I'm going to show you an easier way to figure these problems out. All right, and it'll work every time because these are going to get harder, believe it or not. All right, so remember, this is a function because each domain has exactly one range, and that's what a number machine is. So let's take a look at a real-life example. McDonald's, do you like it? Don't you like it? Doesn't matter. We're going to talk about it. I like it. So you're probably familiar with these things. They're coming up in a lot of McDonald's. They're kiosks, and what they do is they allow you to make purchases on your own without talking to anybody. So you've got definitely the output. You got a cost of your meal. What's it going to cost you? So when you walk into McDonald's, you're going to have to know how much you can spend by how much money you have in your pocket. And then you got your input, and that's what you're doing over here at the kiosk. You're going to make a purchase. One of my favorite purchases at McDonald's is, I feel like I'm endorsing McDonald's, a double cheeseburger. So I'm going to see that button, the double cheeseburger button, and I'm going to click it. And when I click it, what's going on inside the machine? It's going to say $1.99X, and it's saying each burger is $1.99. The next question that's going to ask is going to say quantity, or how many, and it's basically going to leave an open spot, and it's going to multiply that by $1.99. So let's say I'm feeling extra hungry. I want 4. 4 is going to go in there, and before I check out, it's going to ask me maybe, do I have any coupons? And it just so happens right here I do have a coupon. I'm going to save $2 on my next purchase. So what's that going to do to this function up here? It's going to subtract 2. So check out, finally, let's do it. $1.99 times 4. I'm going to count by 2's. 2, 4, 6, 8. Then I'm going to subtract 4. It's like using the distributive property, right? So that's going to be $7.96 minus the $2 coupon is going to give me $5.96. Now, if we have to write that as an ordered pair, we can. Our input was 4 cheeseburgers, or 4 double cheeseburgers, and our output was the cost, $5.96. Input, output. And this would work for any amount of cheeseburgers, right? So if I wanted 2 cheeseburgers, that would be my input, and my output would be $1.98. I could buy 3 cheeseburgers, input, and my output would be $3.97. I could buy 5 cheeseburgers, and my output would be $7.95. So you can write a lot of different ways, and it'll work for any amount of cheeseburgers, and it's always the same function. And yes, it is a function because each time you buy a different amount of burgers, it's going to cost a unique amount of money. So that's why it's a function. Remember, each domain has exactly one range. All right, so what would that look like if we graphed it? We're going to graph them burgers here. And we've got these 3, the last 3 that we looked at. I've got my graph, and remember, this is the x-axis and the y-axis, but in this case, they have more specific values. It's called the burgers on the x-axis and the cost, all right? So let's graph and see what it looks like. I graph the points, two $1.98, 3 burgers, $3.97, and 5 burgers cost $7.95. And that's what the graph looks like. And you see, ooh, that pattern, again, that we talked about the other day, it's linear, it's straight, it makes a straight line. All right. And it's pretty cool because now I can say, hey, I left out the value that I initially wanted to buy. Remember, I wanted to buy 4 burgers. So if I go over to 4 on the x-axis, that's 4 burgers, and I follow it all the way up here, I'd say, geez, that looks like it's the cost right there of 4 burgers. And I would follow it over here, and I'd say, well, geez, where does that cross right there? It looks like it's somewhere between 5 and 6. It's closer to 6. And remember, it was 5.96 or something like that. It's always easier when we label the points like this, because we can tell exactly what we're talking about. If I just look at the graph, I can kind of get close and get a good idea, but I'll never really know. So always label your points, and we can tell that it was for cost $5.96. All right, so let's look at some problems that you're going to see in the next section of your work. All right, example number 1. It says 4x minus 3y equals 6. And the directions are going to say, is the ordered pair solution? And this is the ordered pair, 6, 6. And remember what 6, 6 is. 6 is x and 6 is y. So it doesn't matter. We could flip-flop those. But what we're going to do is every place where we see an x, we're going to put the x value. In this case, it was 6. And every place where we see a y, we're going to put the y value, which was 6 also. So now we're going to solve this equation and basically see, does the left side equal the right side? The left side, I've got 6 times 4 is 24. I have 3 times 6, which is 18. And 24 minus 18 is 6. 6 equals 6. That is a yes. That's a good check mark. That does work. The ordered pair is a solution. So if it wasn't true, I'd have a different number equaling a different number. They wouldn't be equal, obviously. Okay, let's look at example number 2. Example number 2 says, solve the equation for y. It's always nice to have an equation or a function in y-intercept form. That means solving for y. So let's do it. I want to get the 4y by itself first. So if I want to get that by itself, I'm going to get rid of the entire 2x term. And these are going to cancel. And I've got 4y equals, and I always like putting the term with x first. And you're going to learn why later. But it says 4y equals negative 2x plus 16. Now finally, to isolate y, I'm going to divide every single term by 4. Okay? Dividing that entire side by 4 is the same thing as dividing each part of it by 4. So watch what happens. The 4's cancel, and I get y equals negative 2 divided by 4. I'm going to simplify that. That's negative 1/2 x, and the x could also go on top. And 16 divided by 4 is 4. So this is what the equation looks like when I solve it for y. Y equals negative 1/2 x plus 4. And that's how you solve an equation for y. Okay, and the third and final problem that you're going to see, the problem is going to say graph the equation. It's just going to give you this equation or function. And you're going to say, well, how the heck do I do that? Well, what we're going to do is we're going to use our t-chart, and we're going to use this. And just like our burgers problem, this is the function. I'm multiplying something by 3, and I'm going to add 1 every single time. And if you're like me, you like to make problems easy. So the easiest the easiest numbers really that you want to use is 0, 1, and 2. You won't always want to use them, but in this case, they're easy. So watch. Let's use 0, 1, and 2, because we want to make our life easier. And I'm going to put 0, 1, and 2 in for the x values right here, just like our burgers. And now let's finish. Let's solve for y. Let's solve for the output. 3 times 0 is 0. 0 plus 1 is 1. So when the input is 0, the output is 1. Next, when I insert the 1, 3 times 1 is 3, plus 1 is 4. So 3 plus 1 is 4. Input 1, output 4. And finally, 3 times 2 is 6. I'm going to do this mentally. 6 plus 1 is 7. 2 input would cause 7. So let's graph these points now. And this is finally it. These are ordered pairs. This is a relation, right? So 0, 1 is going to go right here. 1, 4 is going to go right here. and 2, 7 is going to go right here. And at home, when you're graphing these, you're going to want to have a ruler or a straight edge of some kind and put it right against those dots. I have the power of the computer, so I can just say voila, and boom, I got a line. So that's how you graph the equation. So every problem that you're going to encounter in the next section you've seen here, they might be a little bit different, but they're all kind of around the same idea. You're going to have some tough questions where you're going to say, hey, wait, they didn't give me an X. Or, hey, wait, this is not solved for Y. All right. And those, do your best. Read the notes in the section, and that'll help you. And we'll go over the examples, or we'll go over the problems later, actually. So do your best. Remember, don't be intimidated. Ask questions, and hopefully you guys are doing well. So good luck, and we'll be talking to you soon.